Okay, so I'm going to be taking up question 36 from the extra multiple choice on Google Classroom. The question reads as follows. 100 grams of a mixture of calcium carbonate and calcium oxide was completely decomposed by heat, leaving 64.8 grams of calcium oxide. And they give you the formula for the decomposition of calcium carbonate. And they're asking you for the mass percentage of calcium carbonate in the mixture. So it's a bit of a weird question because like you have like this mixture, but like only the calcium carbonate decomposes. So a really nice picture to that I drew here to sort of wrap your mind, help you wrap your mind around it is this. So you can think of these two squares as our original mixture. You have calcium carbonate and calcium oxide. And we know that it weighs 100 grams. And we're saying that after it decomposes, only the calcium carbonate will decompose into calcium oxide and carbon dioxide. And that's what this formula describes right here. The original calcium oxide doesn't do anything, it's just sort of sitting there. So something that might actually help you to go through this problem is you can sort of think of the mixture as a whole as a big, you can call it impure calcium carbonate, where the impurity is there's like some calcium oxide in there. It's not 100% calcium carbonate. And this sort of, if you frame it in that way, then the question is sort of asking you for the purity of the mixture. How much of the total mixture is pure calcium carbonate, which actually undergoes the reaction. So now that we thought of it like that, this is like the key insight that you have to draw. Because if you want to do anything with this reaction, you don't really have, from what the question gives you immediately, you don't have any information to solve it. They give you the weight of calcium oxide and the calcium carbonate, which you can't really plug into here directly. They give you the weight of calcium oxide that is left over after the decomposition, which is the combined weight of the newly produced calcium oxide from the reaction, because produces these two things. This is the combined mass of the newly produced calcium oxide and the old calcium oxide, but you can't really use that in the formula either. So the key insight is this. Notice that these are both 100 grams, right? Law of conservation of mass. So these both have to be 100 grams. Now, they're giving you that the total mass of this calcium oxide is 64.8 grams. That means that the mass of carbon dioxide by itself has to be 100 minus 64.8, 35.2 grams. Now, why is this useful? Well, since we know the mass of carbon dioxide, using its molar mass, we can find the moles of carbon dioxide. And if you know the moles of carbon dioxide, you can do stoichiometry, and I guess we'll go through those steps one by one. So let's convert the mass to moles. So here we have mR equals m over n, so n equals m over mR. So our moles of carbon dioxide is going to be 35.2 grams divided by the molar mass of carbon dioxide, which is 44.01 grams per mole. So this leaves us with 0.7998 moles of carbon dioxide. 0.7998 moles of this guy. Now, we want to find how much calcium carbonate is needed to produce 0.7998 moles of this. And the ratio is 1 to 1. So that's really simple. That means we had 0.7998 moles of calcium carbonate. Now, how much does that weigh? Well, we're going to have to use the molar mass again. So m equals mR times n. The molar mass of calcium carbonate is 100.085 grams per mole times 0.998 moles will give you 80.048 grams. So that means that out of this 100 gram mixture, 80.048 grams of it is pure calcium carbonate, which undergoes the decomposition into these two products. This, which is left over, is like your impurity. Although the question doesn't call it that. So yeah, 80.048 grams of the 100 grams. That's just 80%. You do 80.048 grams divided by 100 grams, and then times 100 because it's a percentage. So that leaves you with 80%, and that's option D on the multiple choice. So that's how you solve it.